This is video 814, and the goal of this video is to factor completely. So you guys have been working on factoring a lot, and you're getting really good at it, but now we're going to talk about factoring completely. When we factor completely, the goal is to completely make everything so it's as simple as possible inside of each parentheses. So let's talk about what that means. The first extra step you're going to have to take now when you're factoring completely is to look at all three terms. So the 10x squared, we're going to put it in these boxes here, 25x, and the 15. And we're going to ask ourselves, what number, what's the largest number and or expression can we put right there that goes into all three of these terms? So what number goes into 10? What number goes into 25? And it goes into negative 15. It goes into all three of those. Well, the number in this case is 5. All three of those can be divided by 5. Now what we do is we factor it out. So we're going to unmultiply it because 5 times something gives me 10x squared. Well, 5 times 2x squared. That gives me 10x squared. And again, 5 times something gives me 25x's. Well, 5 times 5x gives me 25x's. And then 5 times something gives me negative 15. 5 times negative 3. And remember, these somethings are because, remember, this 5 can copy to the opposite side. So check it. 5 times negative 3 gives me negative 15. Because they all had a common factor, a factor that goes into all three of those, they all can have 5 in them, we can rewrite this expression in a new way. And the new rewriting is 5 times 2x squared plus 5x minus 3. This expression in red is equal to the original 5, 2x squared plus 5x minus 3. These are equivalent expressions. Now I'm not done yet, but I started on the path of factoring completely by taking out the biggest number that they all have. Now I keep going, and what I'm going to do now is take this section right here, and I'm going to put it and factor it even further into a pair of parentheses. And now I'll use my generic rectangle in the process we talked about last week. 2x squared goes here, negative 3 goes there, and we add the 5x to our diamond problem. So this 5, by the way, this 5 that's right here doesn't affect anything I'm doing in these boxes now. It's not going to affect, it's just going to be a part of my final answer. So ignore that extra 5 right now and just focus on the great factoring you've been doing. And remember, this top part of this diamond problem is always going to be the product inside my generic rectangle, so negative 6x squared. So I think to myself, two numbers, they add up to positive 5x, but they multiply to negative 6x squared. So I know one of them is positive and one of them is negative because it multiplies to a negative, and the only way to get a negative is a negative times a positive. In this case, it's going to be negative 1x, positive 6x. Because negative 1x plus 6x equals 5x, and negative 1x times 6x equals negative 6x squared. So negative 1x and 6x go in my generic rectangle. And now I work on the outsides in order to factor this expression. And on the outsides, let's see, 2x squared, the only way to get that is 2x and x. I think I'm going to put the 2x down here because it affects the 6x up here. And so by doing this 2x here, it allows me to get 6x. If I did it here, it would not work. So that's why that one has to be 1x, because 1x works here. Now 1x times negative 1 gives me negative 1x. And up here in this last side that I'm missing, this is going to be 3, because 3 times 2x gives me 6x. I check my final corner by copying things across to make sure, or at least looking at it, and 1 times 3, negative 1 times 3 is negative 3. So I am finished, and my factored parts are 2x minus 1 and x plus 3. So those are my pairs of parentheses, x plus 3 and 2x minus 1. Now is where I copy that 5 down. So this 5 that we saw here, that's part of my solution. All I did was break apart this portion right here, again, into a new section. So I've actually found a third thing that's equivalent. And the third expression that's equivalent is 5 times x plus 3 times 2x minus 1. All three of these are equivalent. And the three that I'm talking about are these three here. This equals this equals this. But the correct solution to factoring completely is this final answer here, because I've written it as factored as I can. Because there are three things being multiplied, and the inside of the parentheses are as simple as possible. So factoring completely really just involves one additional step at the beginning. So let's talk about another problem where this first step is a little bit different, but still we're going to find one number to take out of everything. So again, we start with a 3 square box because we're looking for a common factor. I'm going to put my three terms in here, 24x squared and 45x's. Clean that up a little bit so it's easier to read. So we are now looking for that first step where we're going to find one number. That number is going to go here. That goes into all three of these terms. All three of those can be had with this one number. Well, hopefully you see that maybe 3 goes into all of them, because 3 goes into 3, 3 goes into 24, 3 times 8, and 3 actually goes into 45 as well. You can check that in your calculator, but 3 times 15 is 45. But what's also unique about this one is they all have x's. Do you see all the x's in all three of them? Since they all have x's, I can actually not just take out 3, but I can take out 3x. So my greatest common factor, the largest thing that goes into all three of these, is 3x. Now let's see, 3x times something gives me 3x to the third. 3x times x squared. Because an x squared times an x will give me 3x's. Then I look for the next one. 3x times something gives me 24x squared. Well, I know 3 times 8 is 24. And since this is x and this is x squared, I need another x. So it's going to be 8x. And then I do the last one. 3x times something gives me 45x's. 3x times 15. So at this point, I factored out a 3x, and I've rewritten my expression as 3x times x squared plus 8x plus 15. This is equivalent to the original expression. Then we use everything you've already been doing with factoring, and we factor the inside of the large parentheses further. So we're now going to factor this x squared, 8x plus 5 expression a little bit further, doing everything you know. So again, we forget about the 3x, and we focus on the two parts on the outside. So we have, and I'm sorry, I wrote something wrong here, didn't I? This should have been 15, not 5. So this is going to be 15. And then the 8x, of course, goes in my diving problem. So that 3x that was here is just going to copy, and it's going to be part of my final solution, but it has nothing to do with the rest of this factoring, because we're only factoring what's in this green box here. So now we fill in the rest of our diamond problem by timesing 15 times x squared. And now we think of two numbers that add up to 8x, but multiply to 15x squared. Well, these are all positives, so this should be a little bit quicker when it's positives. And what adds to 8x is 3 and 5, and it also multiplies to 15x squared. So it's going to be 3x's and 5x's. Now we fill in the outside again. This is pretty quick because it's simply x times x here. I like to copy across so I can keep track of everything. And then I end up with 3 because 3 times x is 3x. Copy across. I end up here with 5. 5 times x is 5x. And last but not least, I check this final corner and I make sure I get 15, which I do. 3 times 5 is 15. Now I copy this expression, x plus 3, x plus 3. That's one of my parentheses. The other parentheses is the height of the rectangle, x plus 5. So my final expression and my final solution is what you see here. This is the correct solution to the question that asks us to factor completely, because it's written in simplest form, where inside of each parenthesis is the simplest expression possible inside of each parenthesis. That's as factored as it gets. So there's your final solution. Again, this is an equal. This is the same exact value as all of this up here. It's just written in a different way, and it's factored completely. In Chapter 10, you'll realize why we're factoring completely, because it's going to allow us to simplify things and make our lives a lot easier when we look at harder problems. So factoring is key for the long run here. So we will be getting you some help on this. Now you're trying the next set of problems that are on your worksheet, asking questions as you go, and then we'll have a concept check at the end. Good luck, and ask lots of questions.